Hello everyone, welcome back to my channel. Today we're going to learn how to run ANOVA test in Python. ANOVA stands for Analysis of Variance that compares group means across different levels of one categorical variable, meaning that it compares two or more levels to see if there is a difference between sample means or not. So let's get started. We have a dataset for Amsterdam housing. It has 82 features, columns, or variables. But we're only interested in heating variable, which has 6 levels or 6 sources of heating, naming floor, gas A, gas W, grav, oath W, and wall. We want to know if there is a difference between the mean price of the house considering different levels of these heating sources, and if so, which one is the different one. So go ahead and open a Jupyter notebook. I've written the codes before and we just run it here, but of course I'm gonna clarify the codes for you in each step. First of all, like always, we import libraries and packages that we will use in this test. Import pandas and numpys as PD and NP respectively, and the rest of the packages and libraries. Then we're going to load the data set and then see the first 5 rows and the columns using head method. Then we're going to test the assumptions of ANOVA and see if they are met because they are necessary for doing the test. So assumptions are independence of observations, normality, and equality of variances. Independence of observations means that all groups are mutually exclusive and one observation cannot fall within 2 categories, which in the case of this example, this assumption is satisfied. For second assumption or normality, we use QQ-plot to visualize if the data is normally distributed or not. Our target variable, of course, here is sale price. So we use QQ-plot from Stats Models Graphics. You see this plot is skewed towards right, so we need to apply log transformation on sale price column and then plot it again. So we do it and you see now that the data points are tightly coupled around the straight line. And now we can say that data is normally distributed. And finally, for the third assumption, equality of variances, we tested using Levene's test of homogeneity of variance. Here we analyze heating variable. So null hypothesis for this test is that variance for all groups is the same. So you see the p-value is 0.127 and it is greater than 0.05. Therefore, we fail to reject the null hypothesis and conclude that treatments have equal variances. Now that we see all the 3 assumptions are satisfied, we're good to go and conduct the ANOVA test. We have 2 approaches to run the ANOVA test in Python. One is with the stats.f_ one-way method, and the second one using OLS model. As we know in regression, we can regress against each input variable and check its influence over the target variable. But here we use the first method or the first approach, and we run the ANOVA test. The p-value for the test is less than 0.05. Then we can conclude that at least one group means is different from others. You know that one-way ANOVA only tells us that at least one group mean is different, but it doesn't tell which one is different. In order to identify that, we will run another test that will do pairwise comparisons between all these groups, and it is called Tukey test. Notice that group is the heating variable here, and as always, alpha is 0.05. So then we print Tukey. Here is the results. The test results show that the difference in mean of sale price is statistically different for the following levels of heating categorical variable: gas A or gas first warm air and grav, and gas A and wall, and gas W or gas hot water, and graph, and lastly gas W and wall. For the rest of the heating variable levels, sale price is not statistically different among groups. So that was it. It was the process of conducting ANOVA test in Python. I hope you liked it and find it helpful, and I'll see you in the next videos.